Good morning, sir. This is Pratibha from CSCA section. Today I discuss about the introduction to stream concepts. Streams are a way of handling continuous, unbounded data in real time. They are used in systems that process large volume of data as it arrives, without storing the entire data set in memory. What is a stream? A stream is a sequence of data elements made available over time. Unlike batch processing, stream allow real-time data handling. For example, Twitter feeds, stock market prices, sensor data. Key characteristics of stream: unbounded nature, real-time processing, and immutable data. Unbounded nature means data keeps arriving continuously. Real-time processing means processed immediately as it arrives. Immutable data. Once data is generated, it cannot be modified. Types of streams. There are two types of streams. One is data stream and another one is event streams. Data stream means contain raw unprocessed data. For example, sensor readings, clickstream logs. Event stream means represent specific events in a system. For example, user login or payment transaction. These are the types of streams. And components of a streaming system is producer, stream processor, consumer. Producer means generates the data. Example, IoT device, social media app. Stream processor means process the incoming data. For example, Apache Flink, Kafka streams. Consumer, it means receives and uses the processed data. For example, dashboard database. These are the components of a streaming systems. Benefits of streams: real-time insights and analytics, scalability to handle large data volumes, improved decision making with live data. Tools for stream processing: Apache Kafka and Apache Spark Streaming. Apache Kafka means distributed platform for building real-time streaming pipelines. Apache Spark Streaming means real-time data processing framework. And the example for stream processing is stock market analysis. Stock market analysis is streaming platforms process stock price updates in real time to provide traders with live analytics and alerts. This is the example for stream processing. Stream data model and architecture. The stream data model and architecture defines how streaming data is processed and managed in real-time systems. It focuses on organizing, transporting, and analyzing unbounded data efficiently. What is a stream data model? The stream data model represents a continuous flow of data as unbounded sequence, immutable records, temporal records. Unbounded sequence means data arrives continuously without an end. Immutable records. Each record is a snapshot of an event at a specific time. Temporal order. It is data is ordered based on timestamps. Components of stream data models: events, stream, and operators. These are the components. Event means basic unit of a data in a stream. Example like a click on website, a sensor reading. Stream means a sequence of event flowing in real time. For example, Twitter feed, stock market ticket. Operator means functions applied to stream for processing. Example like filtering and aggregation. Stream architecture. Key components are data producer. It means generate raw data in real time. For example, IoT device, mobile apps. Data ingestion captures and sends data into streaming pipeline. Tools like Apache Kafka and Apache Kindness. Stream processors process, analyze, and transform the data in real time. Tools like Apache Flink and Apache Streaming. Data storage means stores the processed data for future use or querying. Tools like Hadoop Distributed File System and Amazon S3 and Elasticsearch. Data consumers is end users or systems that use processed data. Example like dashboard machine learning models. Stream processing models are stateless processing and stateful processing. Stateless processing means process each event independently. For example, filtering invalid data points. And stateful processing means it means maintains intermediate results state for operations like aggregation. For example, counting events over a time window. These are the stream processing models. Tools for streaming architecture. Apache Kafka, Apache Flink, and Amazon Kinesis. Apache Kafka means it handles data ingestion and distribution. Apache Flink, it, uh, it is real-time data processing with stateful computation. Amazon Kinesis, cloud-based streaming solution. These are the tools for streaming architecture. Example for streaming architecture is e-commerce. E-commerce recommendation system. Producer. User browsing behavior on a website. Ingestion. Data is streamed via Kafka. Processing. Flink process user action in real time to generate recommendation. And consumer. Displays recommendations on the user's screen instantly. This is the e-commerce recommendation system example. And stream computing. Stream computing, also known as stream processing, refers to the real-time processing and analysis of continuous data stream. It enables organizations to gain insights and take immediate actions on data as it flows into the system is known as stream computing. What is stream? Stream computing involves processing unbounded streams of data in real time, applying computations such as filtering, aggregation, and transformation on the data as it arrives. Characteristics of stream computing: real time processing, low latency, continuous flow, scalability. Real time processing means data is processed as it arrives. Low latency means results are generated instantly or within milliseconds. Continuous flow means data is handled continuously without stopping. Scalability means it can handle large volume of data efficiently. These are the characteristics of stream computing and how stream computing works. Workflow are data generation, data ingestion, data processing, and data output. Data generation has it continuous flow of data from sources like IoT sensors, web applications, or social media. Data ingestion means data enters the processing system via tools like Apache Kafka or Amazon Kinesis. Data processing means in real-time computations are performed using tools like Apache Flink or Apache Spark Streaming. And data output is the processed data is sent to dashboards, database, databases, or applications for further use. These are the stream computing works. Key components of stream computing: data sources, stream processing engine, data storage, data consumers. Data sources means devices or applications generating data. Example, sensors, user interactions. Stream processing means engine. It performs computations on the data streams. Example, Flink, Spark Streaming. Data storage is it stores processed result for future reference. Example like Hadoop distribution file system and NoSQL databases. And data consumers are the applications or systems using processed data. Example, dashboards, alert systems. These are the key components of streaming computing. And applications of streaming computations are fraud detection in banking, real-time recommendations, IoT monitoring, social media analytics. These are the applications of stream computing. Fraud detection in banking, identifying fraudulent transactions as they occur. Real-time recommendation means generating product suggestions for users on e-commerce websites. And IoT monitoring is the analyzing sensor data in smart cities or industrial equipment. Social media analytics are tracking trending hashtags or analyzing user sentiment in real time. These are the applications of stream computing. And tools for stream computing are Apache Flink, Apache Spark Streaming, Amazon Kinesis. Apache Flink means distributed system for stateful stream processing. Apache Spark means Apache Spark Streaming means real-time data processing built on Spark. And next one, Amazon Kinesis is cloud-based systems platform for ingesting and analyzing data. These are the tools. And real-world example is ride-hailing services means Uber, data generation, GPS, data from drivers and passengers, processing, stream computing calculates optimal routes, predicts arrival times, and matches drivers with riders. And the output is users receive real-time updates on driver location and trip details. This is the example for stream computing. These are the concepts of stream processing. Thank you, sir.